Welcome back. This is Mr. Wakefield looking at section 4.5 right now. And we're going to be looking at solving one variable equations once again. In fact, we're going to be looking at something that we saw in 4.2. But as I promised you in 4.2, the 4.2 method cannot always work. All right. In particular, we're going to be looking at exponential equations. That's an equation that has a variable and an exponent. Thus, they call it exponential. Looking down here and taking a look at these 5 problems and then comparing them to some of the ones we did back here in 4.2 that I'm looking at right now on the screen. What were we able to do in section 4.2? First of all, we were able to get the equation to look like this. All right. Unfortunately, here in this current section 4.5, with the exception of one of these 5 problems, and we'll get to that here eventually, we cannot get it to look like that. We cannot do that A, B, A, C thing. For example, I've got 1/3 of the x and then I've got 6. All right, I can't make the 6 to be 1/3 to a power, and I can't make 1/3 to be 6 to a power. I can't make both sides look like that A to the B, A to the C type of formula where I can get the exponents and set them equal to each other. So what do I do when this type of format is not possible right here? What I do as an alternate is, first of all, I need to ensure, this is very, very important, or otherwise you're going to get the thing completely messed up. Make sure that the exponential expression is by itself, isolated in other words. What do I mean though by exponential expression? That is just the base and the exponent. Okay, kind of like what we talked about in the last section where I said that, let me pull that out here. Remember this property that we looked at in the last section where I said that you can't use this property unless it is a base and an exponent only. Well, same thing here. And the reason why it's the same thing in this section as it is right here from what we talked about before is because we're going to be using a variation of this very property right here. And so that's why this has to be just a base and an exponent. In the current problems, along with this property, the ones we're about ready to look at have to have just the base and the exponent. So is that the case here in problem number 1? Do we have the base and an exponent by itself on one side? And in particular, not just any base and exponent, but it has to be an exponent that has the variable in it. Okay, so do we have just a base and an exponent with a variable in the exponent? Yes, we do. All right, that's what they mean by the exponential expression, the base along with the exponent that contains the variable. So since we have that now by itself, we can now take a log of both sides. In particular, I like to usually use ln. It doesn't matter if you do ln or if you do log base 10, because either way, your calculator can help you get to the answer. I just put ln here just to pick something, but you could do log base 10. So let me go ahead and do what this is saying here is that if you've got 2 things that are equal to each other, you can then take ln of both of those things like this. Remember, you're taking the ln of those things, which makes those 2 things 1/3 to the x and 6. Those 2 things are now product terms of the ln. Remember, you're not multiplying by ln. That's impossible. Okay, ln is like log. It means nothing without the product term. All right. So you're just taking ln of both sides, which makes it so that those 2 things that you originally had in the beginning of the problem are, again, product terms for the ln. Again, why does this work, you guys? Is because that same property that I was just talking about is now something that you can use, okay? In fact, I mentioned it up here. That same property, it's just that now it's for ln instead of log, but that's okay because ln is a type of log, so that's why that property still works. The one where you take the exponent and move it to the front. But again, you can only do that if your product term is just a base and an exponent only and no other stuff. All right, so you got to move the x to the front now, like this. And then what I want you to realize at this point, I know it doesn't look like this, but ln of 1/3, okay, and ln of 6, those two things are constant numbers, all right? Anytime you have ln and your product term doesn't have a variable in it, remember, the variable is in front of the ln. That means it's not a part of the ln. Anytime you got something in front of an ln or a log, it's not actually a part of the log. It's just getting multiplied by it, okay? So if you have ln with a product term that has no variable in it, and also the base has no variable either, which it doesn't, it's just that number, that invisible number e right here, then that whole thing is a constant number. So what I wanted to point out here is that this is no different, you guys, than if you had, say, for example, x times 4 equal to 8. X times 4 equal to 8. Okay, because 4 and 8 are constant numbers just like these two ln's are, due to the fact that they don't have any variables in them. And so you just do the same thing in this current problem that you would do in this pretend problem that I just wrote down. You would divide out to get the x by itself. Wouldn't I divide by 4 right here to get the x by itself? Sure. Okay, so in the same way, I'm going to divide both sides of this equation by the thing that's being multiplied by x, which is ln of 1/3. Not just ln, but ln of 1/3. Remember, ln is nothing by itself, but ln of 1/3, that's an actual number. Only our calculator knows what it is, but that doesn't change the fact that ln of 1/3 is a number, and that number is being multiplied by x, just like the 4 is, and so you divide by it in order to get the x by itself. So now, what does this all mean? It says here, except for number 3, and we're doing number 1 right now, obviously, so round the final answer to 3 decimal places. So what I do is, and this is very similar to a problem that we looked at just in the previous worksheet, okay, where we had ln of 2 divided by ln 1/3. Very, very similar thing. Just enter the current problem in your calculator the same way we did this one. Okay, you got the fraction on the bottom, normal number on the top. It's just that the top has 6 now instead of 2. No, that does not mean the answer is 3 times as much. It doesn't work that way because ln's affect that. It changes that. But your calculator will tell you what it's equal to, though, and that's what's important. So let's see what we got. We get ln of 6 divided by, and again, use your brackets here for the fraction part like we talked about. And I get this right here, negative 1.63, and then since it's 09, that means that I want to do what? I want to do, I want to round that up to 1.631. 1.631, okay, and let me write that down. Negative 1.631, as my calculator says. There we go. All right. So we did it. We solved for x like we always do when they ask us to solve a one variable equation. Next one here. You can see here that once again, the base and the exponent, x to the 4th is the exponent. I know it looks weird because you have an exponent inside of an exponent. All right, but x to the 4th, because it's raised up, that whole thing is your exponent. So we have a base that's a constant along with a variable in your exponent, and those are the only two things you have, the base and the exponent on that side of the equal sign. So that means you're allowed to do that same thing again, where you take the ln of both sides, like this. All right. And then after I do that, just like in the last problem, I take the exponent and I move it to the front. I want you to notice something here, though, that's going to help us here a little bit. What is ln of e equal to? Well, that is log base e of e. All right, and log base e of e is asking e to what power is equal to e. Okay, that's what that thing is asking us right there. It is asking us, since e is the base and the product term is e, it's saying e to what power is e. Isn't that 1? Okay, isn't e to the first power equal to e? So whenever you see ln of e, you guys, and I don't mean ln of e and something else. I mean just ln and e. That's it. Okay? ln of e, that is always equal to 1. That whole thing just becomes a 1. And so this is x to the 4th times 1. So doesn't the ln of e just cancel out? Because when you multiply by 1, you don't need to write it, do you? All right? X to the 4th times 1 is the same thing as just having x to the 4th only. And so it's as if the ln of e just canceled out. All right? Move that exponent to the front, though, first, and then that's what makes this equal to 1 right here. And then it just cancels out because you're multiplying by the 1. Another thing that we looked at a few sections back, see where it says that x to the 4th is equal to a constant number. Again, if you have an ln with no variable in it, okay, if the whole thing has no variable in it, that's a constant number. And as we talked about at the end of section 4.2, if n is even, which 4 is, okay, and you have x to the 4th equal to a constant number, then you do that double root thing, but it's going to be 4th root on both of these. Okay, but because it's even, you do have to do both of these radicals. So this is what it's going to say. It's going to say x is equal to plus or minus, because you got to do both radicals, the 4th root of, let me zoom in so you can see that, the 4th root of ln 1000. Okay, plus or minus the 4th root of ln 1000. So again, we got x by itself. We're on our way now. The only thing I got to do now is, since the problem said to do rounding off to 3 decimal places, I am going to figure out what ln of 1000 is. All right, because you got to figure out the inside of a square root before you can, or the inside of a 4th root, any radical. You figure out the inside of a radical before you figure out the radical itself, if they want you to figure out what the whole thing's equal to. So that's ln of 1000. I then want to take that to the 4th root. So here's how you do it on one of these 2-line calculators. You need to find the root that is not the square root but the alternative roots. It's above, in this particular calculator, it's above this button. It's the one where, let me show you. It's the one that has like a variable. It doesn't necessarily have to be x, but it has that variable with the radical there. And if it doesn't have the variable there, if it just has a radical, then that's square roots on your calculator. But this one is meant to be used for 3rd roots, 4th roots, 5th roots, and so on. So what you do is you first of all hit 4, because it's going to be the 4th root. Then you hit that button right there, and then you hit this thing called ANS. That's the answer. It's usually down here near the bottom of the calculator, and it takes the previous answer that you got, which was the ln of 1000, and it puts it in there. And so there it is, ANS for the answer. So that's the 4th root of that, and there it is right there, 1.621. Okay. So the final answer is what? And you know what? Hold on. Oh no, that's right. That's right. Never mind. 1.621 plus or minus, because remember it's plus or minus as it says on the previous step. There we go. On the 1-line calculator, we're going to have to do things a little bit differently because it doesn't have that ANS answer button on it, but that's okay. We'll get through it. First of all, you do the ln of 1000. And then what you do is you need to realize that whenever you have the 4th root of something, that is the same thing as taking it to the 1/4 power. All right, you don't have to write this down, but the 4th root of ln of 1000 is the same thing as taking the entire inside of the radical, like we talked about the last few sections when we review that, and taking it to the 1/4 power. And so what you can do then is take that ln of 1,000 that's already on your screen and just hit the exponent button here like we've done before, and then say either 1 divided by 4. But you got to put that in brackets if you do that. Otherwise, they'll think that you're just doing an exponent of 1, and then you're dividing the whole thing by 4. We don't want that to happen. Or you can convert the 1/4 to a decimal and make that what you're going to do. Make that your exponent. But I'm going to do, I'll just do the bracket 1 divided by 4. Like that. Close. Don't forget to close the bracket. There's your exponent right there. They computed it for you. And then you hit the equal sign and you get the same exact answer. Okay, so again, when you take something to a fraction power, once again, put that fraction in a parenthesis. Don't forget to close up that parenthesis and you should be fine. Let me know if you're not. Let me know if you're not getting those answers correct. All right, moving on to number 3 now. For the first time, we have a base and an exponent, you guys, that is not by itself here. All right, base and an exponent. See how in the previous 2 problems, your base and exponent, like we talked about, they were already by themselves. So we were able to jump right into that step where you take the ln of both sides. Can't do that here. What we got to do instead is we need to get that red box by itself, because that's the base and the exponent with the variable in it. All right. Again, the very first step says to isolate that red box right there. And how do we do that? As we've talked about in the past, if you want to get something by itself in an equation, pretend like it's a variable. That whole thing is a variable. And then ask yourself, how do I get that variable by itself? Wouldn't I subtract the 1 and then divide the 5? To get the y by itself? And so wouldn't it make logical sense to do the same exact steps in the real problem as well? Let me write that down. So I am going to subtract the 1 over. The 1 cancels out on the left right there. And then I divide both sides by 5. Okay. Normally you wouldn't have to do this, but this will really clear up some things here and make things easier. What is 6 divided by 5? Normally you can leave it as a fraction, but what is that as a decimal? And that'll really help us out here. 6 divided by 5 on your calculator actually is 1.2. Same number as we have over here. This is important because as we learned back in 4.2, when you have something that looks like this right here, you can use this, and it's typically easier than doing the ln of both sides and all that stuff that we're learning right now. So as you can see here, 1.2 is the same thing as 1.2 to the first. All right, and if you have 2 constant bases right here that are both exactly the same, 1.2, 1.2, all right, where it looks, again, it looks like this right here, a to the b and a to the c, all right, then that means that you can cancel out the bases, and you just get that simple little equation right there. Again, it has to look like this, meaning you don't have anything else, you guys, other than the base and the exponent on each side. And of course, the bases have to be the same constant number. Now that I've done that, everything else goes real nice here. It's just a nice little linear equation. You add the 2 over to the other side, you divide out, and you get a nice little simple answer of x equal to 1. That's why I said you don't need to round off in problem number 3. It's because it's just a whole number answer. Let's keep going here. Number 4. All right. Again, you have a base and an exponent, but this time you have a base and an exponent on both sides. All right. So it kind of looks like, this problem right here that we saw in the past in 4.2. But again, unlike this problem here, you cannot take the 3 and the 7 and make a common base out of it. We were able to do that with 32 and 16. They were both equal to 2 to a power, and so I was able to redo the problem with 2 being the base on both sides. Can't do that with 3 and 7. So if you do have a base and an exponent isolated on both sides instead of just one side, you can still do that ln thing, all right? But they do need to be isolated, and they are here, okay? Whether it's on one side or on both sides. So here's what it looks like, okay? Now, like we've been doing, whenever you take ln on both sides, you then take the exponent and move it to the front of the ln. But because it's got 2 terms in it, and because you're multiplying it by the ln, then as we've said many times before, if you have something with more than one term in it, which these exponents do, and you're multiplying it by something, in this case the ln's that are behind it now, you got to bracket those. More than one term, you're multiplying it by something, you got to bracket it. Okay? Now here's where it gets a little bit interesting here. As we've said before, ln of 3 and ln of 7, because those are ln's that don't have a variable in it, all right? Those are constant numbers right there. Those are constant numbers. So this is no different than if you had this right here, x minus 4. Let me just give you a visual here. X minus 4 times 2 is equal to, say, 2x plus 5 times, say, I'll just make up another constant number here, 3. All right, zoom in there. So how would I solve this equation? I would distribute. It would give me a normal linear equation. I would then get the x by itself in the normal way. All right, I'm going to do the same steps down here. You just got to be careful because these are ln's now that you're multiplying instead of just simple numbers like 2 or 3 right there. So you just like I distribute the 2 here, and I distribute the 3 here, you guys, we're going to distribute the ln of 3 like this, and we're going to distribute the ln of 7 like that. But again, that's where you got to be careful. Because when you multiply an ln by something that's not an ln, you got to keep it. You can't combine it. You can't bring the x into the 3. All right. Remember what I said. When you're talking about doing stuff with ln's and logs, you can't just assume that the old rules for polynomials and stuff would work. All right. And no exception here. So if you've got an ln being multiplied by something that's not an ln, it doesn't combine it all. Okay. If you have x times ln of 3. It's just x ln 3. You cannot combine it in any kind of way. All right. You could put the x into the 3 by making it into an exponent, because when you have something on the outside being multiplied by a log or ln, you can make it into an exponent here. I'm not saying you should do that here, but I'm saying you could. That's an example of something you could do. But you can't just multiply something outside of a log or ln into the product term, just like you can't factor anything out of the product term out here. Okay? Be careful not to use the same rules we've used in the past. Same thing here. If you got a regular term that's not an ln or log being multiplied by an ln, just say that they're being multiplied. Don't try to combine anything together there. Same thing over here. 2 regular terms being multiplied by an ln. So 2x ln 7, 2x times ln of 7, that's just 2x ln 7. 5 times ln 7, that's just 5 ln 7. You can't combine anything. All right, and put a plus in front of that because it was positive times positive. Okay, just like you normally do when you distribute. Put a plus or minus in front of each answer depending on the sign. All right. Then what do? Just like I would do up here, I now have 4 terms here, just like I would if I distributed this out, right? If I distributed this out right here, it would be 2x minus 8 equal to 6x plus 15. wouldn't I move over the 8 and the 15 together? And I'd move the x terms over to the other side? Same thing here. Here's the x terms. Okay, please don't be thrown off by those ln's, you guys. Those are just constant numbers. All right, so that entire term there with the x in it is a variable term. And that ln of 7 doesn't change that. It's just like having another number being multiplied by the x there. So just like up here where you have the 2x and the 6x need to be moved to the same side, and you have the 8 and the 15 need to be moved over to the other side. Same thing here in this problem. All right, I'm going to add, or pardon me, yeah, actually I was thinking of, you can do it either way. You can move it the greens either direction here as long as the red ones go on the opposite side. All right, so you move that over. That cancels that out. You then move this over to the other side. Okay, you got to move that whole thing over. Remember, just like up here, the plus and minus separates it into different terms. Same thing here. The minus and the plus separate into different terms. You got to move the entire term over. All right. What do we got here? We got x ln 3 minus 2x ln 7 equal to 5 ln 7. These canceled out. 5 ln 7 plus 4 ln 3. All right. And we've seen this before, I believe. Let me double check. If not, I'll go over it carefully with you. Yeah, we've seen it. When you have two terms on one side, this is way back in the prerequisite review packet. If you've got two terms on one side that both have the variable in it, all right, in this case, the variable was designated to be w. If you got two terms with that thing in it, this is after you move the greens to one side and the reds to the other, you then have to factor out the variable when there's more than one term with that variable in it, and then you divide by that bracket. Let's try that here. Okay, if I factor out the x, I get ln of 3 minus 2 ln 7. All right, because that's what's being multiplied by the x in both of those things there. So kind of an interesting looking problem with all these ln's. We just got to take our time here, be careful. So I'm going to divide by the bracket like I just mentioned a moment ago. And I get that right there. Okay. Sorry about that. That fell off the screen there. So let me say that again. Divide that out. Okay. After you factor out, just like I said over here with the W from this section. All right. Divide that out. Divide by the bracket after you factor that out, and that's going to get the x by itself, just like I got the w by itself. All right. So after all that, we got x by itself, but what is this big huge thing equal to, because they want us to put it in decimal form? Let's talk about that. Use parentheses here, you guys. You don't have to write these down right now, but when you put in your calculator, put parentheses around the entire numerator and the entire denominator. Otherwise, it's going to think that you're only dividing the last term here and the first term here. Okay, you got to bracket it. Let's try that. 5 ln 7, 5 times, and then remember you put in the 7 before the ln when you use this calculator. Okay, then we say plus 4 times ln of 3. Close up your bracket, and there's the numerator right there. So then, again, don't forget to close up that bracket, just like it closes up right here at the end of the numerator. Hit divided by for the fraction bar, and then we have, again, open up a new bracket. We have 3 ln minus 2 times ln of 7. Close up that bracket, and then that will give you the denominator. So now I need to hit the equal sign, and it'll give me the final answer. and it is rounded off. It's going to be negative 5.057. Negative 5.057. There we go. All right. The two-line calculator is basically the same thing, only you, as always, you enter the ln before the product term, but use your brackets on that as well. All right, and you should be fine. All right. Number 5. Once again, it looks very similar to the first problem, doesn't it? All right. Very similar to that, where you've got a base and an exponent on one side by itself and then a constant on the other side. But there's something different about this, and that's that negative sign. What if I were to do my normal thing and say, oh, hey, ln of both sides. Okay, we can do that because the base and the exponent are isolated. Here's the problem. You can never have an ln or a log with a negative product term. That is impossible. Why is that impossible? Because I want to show you something here. This is from a previous answer key that I had. 1/9 to any power has to be positive. How come? It's because any positive number, including 1/9, that's a positive fraction, so that counts. Any positive number to any power at all, doesn't matter what the power is. So the fact that it's x, that could x counts here because it could be for any power. So even though we don't know what x is, since it counts for any power, that counts here. All right. So 1/9 is a positive base taken to any power. That's got to be a positive answer. Anytime you guys got to have a positive base, it doesn't matter what your exponent is, it's got to be a positive answer. So there's no way that this could happen. You can't have 1/9, which is a positive number, taken any power, no matter what it is, and get a positive answer. So there's no way there can be a solution to this because this scenario is impossible. A base and an exponent can never equal a negative answer as long as your base is positive. And it is. All right. But let's say that you didn't discover that whole thing at first. Then you could still discover that there's no solution by realizing that if you have an ln or a log with a negative product term, that's also automatically that's not even a number. There's no answer to that. And so since part of your equation has no answer, in other words, it has an undefined number, then there's no way there can be a solution to that equation. And so either way that you discover it, it's going to end up being no solution either way. All right. Why can you not have a negative product term? It's the same reason, you guys. Remember, a product term is the answer that you get when you take a base and an exponent together. And so since our ln's are always, and our logs as well, since they always have positive bases, and since the positive base leads to a positive answer every single time, there's no way that answer, which represents the product term, there's no way that you can have a negative answer here, and therefore the product term can't be negative. So, no solution. Okay. Can't have, just write this down so that you can look at it later and know why we said no solution. Can't have a what? Can't have a negative product term. All right. And so there you go. So, to review here, get the base and an exponent by itself. Over here it wasn't, so you had to get it by itself. Then if you're able to use this property like we did in 4.2 right here, all right, use it. If you can't, then do ln of both sides and go from there. Okay?